Okay, so for part three, I'm going to be explaining the lever rule and showing how we can determine the relative amounts of liquid to vapor in the liquid vapor equilibrium on a any uh, bubble dew point graph. So if we set up our plot with temperature, um, and then the x-axis is going to be mole fraction of component 1 and 2. And then we set up our plot, the bubble dew plot looking like this, where every point above this line is going to be 100% vapor, and anything below is going to be in the liquid phase. And then, as we've explained in the past two parts, anything in this section is going to be a mixture of vapor to liquid. So now, um, okay, and for reference, this is in between points A and B, where A and B are the saturation temperatures. Now, if we wanted to find the ratio of vapor to liquid at any point C in this space, just for demonstration, I'm going to pick a point in here. Let me make that a little bigger. So this will be point C. Now, if I magnify that area, just as kind of an estimate, if point C is in this area right here, that is point C. If we draw our lines so that we can see where point C lands on the bounds of our vapor-liquid equilibrium, we can, using the lever rule, we can determine the relative amounts of vapor to liquid. So if this is, remember, our vapor above and our liquid below, we can see that point C lands closer to the vapor side, and that means that our ratio of vapor to liquid is going to be heavily favored. It's going to be mostly vapor. And using the lever rule, we can determine relative amounts, basically saying this looks 1/3 and this looks like the other 2/3. And therefore, we can conclude that at point C, our um, solution will likely be 2/3 in the vapor phase and only 1/3 in the liquid phase.